Okay, with any truth table, first of all, you set up however many variables you have. You set up a column for each one and then do all the possible combinations. If you had three variables, P, Q, R, that would be 2 to the third power or 8 different rows. When you just have two like this, you have four possible combinations of true and false. Then the next thing to do is to break it apart. So really what we want to do with the if and only if, we want to see if this part right here is the same as the second part, if it has the same truth values. So in order to get not P implies Q, the first thing would be to get P implies Q. We're really just breaking it down into steps. Before we get the negation of something, we want to have whatever whatever it is, the statement itself. So P implies Q. Remember, this is that broken promise situation. This is going to be true unless a promise is broken. And here is the broken promise situation. So the rest are true. These last two are vacuously true. Remember, just because the promise was never fulfilled in the whatever the if statement was never fulfilled in the first place. So those are vacuously true. And then we can do not P implies Q. And the thing to remember here is we don't need to think of this all at once. All we have to do is think, okay, we're doing the negation. We're doing the opposite of this thing right here, of the P implies Q. So instead of thinking of it all as a single statement, all you're doing is flipping the truth values of this here to get false, true, false, false. And now we go to this statement over here. Again, instead of trying to do this all at once, we get the negation of Q first. We get not Q first. So we're just looking at the Q column and we're flipping all the values like that. And then we can get P and not Q. And sometimes when I'm doing this, I give myself a little star above the column. So I remember that I'm working with this column right now and the not Q. Again, I'm not really thinking of it in terms of a negation. I'm really only focusing on this and, this conjunction here. So I'm looking across there. The only way an and statement is true is if both of these are true. So I'm looking for any column, or any row, sorry, where both of these dotted columns are true. So here's a true, that's good, but this one's not true, so that's going to be false. In order for an and to be true, I have to get both of them true. So here's a true, and here's a true. So this one had both P and not Q were true. Here I have a false. Two falses, by the way, doesn't help you with an and. It's not two wrongs make a right. You actually have to have both of them be true values. So this is as far away from a true and as we can get. Here's true, but this one's false, so this one's also going to be false here. And then if and only if, you could make a separate column for it and basically just make sure that the two columns matched all the way across. Or at this point, we know that the truth values of this statement are right here, and the truth values of this statement are right here. And we can see that every single row matches, which tells us that this is logically equivalent to this. The two statements here are logically equivalent. If we did put this entire thing here on the header of a column, we would be doing true, 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 because here we're just looking at, are the two values the same value, whether it's both falses or both trues. You don't have to do that step, but that would be another explanation. And when it asks and why, you could just say because the two have identical truth values for every row of the truth table. That would be an explanation why.